going to learn about nice and ugly domains. These are the domains which can be defined by imperfect iterative process, which means these are not perfect process, these can be imperfect. Iterative process is nothing but which starts from the defining and collecting data, processing the data and refining, and there can be many stages like product testing, and this is the process of iterative process. Iterative process is nothing but these can be built in stages. Imperfect iterative process means this is not a perfect iterative process, and these can be aimed at achieving user, buyer and voter satisfaction, which means in these nice and ugly domains, here is a plane we can define like this can be considered as in a plane. Here we can write like V11, V2, V12, V13. Here V21, V2, V22, V23, and V31, V32, and V33. This can be defined like V11, V12, V13, V21, and V22, and V23, V31, V32, and V33. These can be achieving by the three stages like user, buyer and voter satisfaction. Like these can't be incomplete, which means this should not be incomplete, it must be complete. In this process it cannot be incomplete or inconsistent. Okay, next, firstly, every input is positive, which means we can be having like 1, 2, 3 or 4 like this. Every input should be processed and none of the input will not be processed. Inconsistent domains can be made into consistent, which means these are the two linear lines can be considered as a consistent lines. Whether these are the lines, these cannot be any consistent lines. In these cases, these lines can be made into consistent model. Some properties of nice domains are linear and non-linear boundaries, complete boundaries, systematic boundaries, orthogonal consistency, closed, convex and simply connected. These are the properties of nice domains. Linear and non-linear boundaries in nice and ugly domains. Here we are going to learn about first properties of nice and ugly domain. Here, nice domain boundaries are defined by linear inequalities or equations. In these we have linear equations like y is equals to mx plus c. This is a linear equations which can be defined. In these linear and non-linear boundaries, we can have 2 points to define the straight line. Nextly, and 3 points to define a plane, and n plus 1 points to define n-dimensional hyperplane, which means n plus 1 means undefined points can define undefined dimensional hyperplane. In these, mostly all boundaries predicates can be either linear or non-linear boundaries, which means nothing but in these linear and non-linear boundaries, 99.9% all the points can be converted into linear or non-linear boundaries.